A very good morning and a warm welcome to one and all present over here, teachers. Thank you so much for joining on another Super Sunday workshop. And this time we are getting into the topic of skill labs. Last time we touched upon something called as integrated learning and teaching. And this time skill labs. It's actually connected completely to each other. There has been times when people have always been prioritized skills over concepts or concepts over skills. What is really important according to you, you can put that on the chat. Now, why are we discussing about concept and skill in two different formats? It's because there is a sudden surge in the need of skilled knowledge. Now, what do you mean by skilled knowledge? We're going to touch upon that particular aspect in our today's session. Skill labs has been growing since 2011-12 across various states in the country, and not just in India. It's a global phenomenon. In fact, certain curriculums like International Baccalaureate curriculum and the IGCSE curriculum, the Cambridge curriculum, has been talking about setting up an innovation hub, a place where the children can separately come, use all their knowledge of various disciplines and subjects, and come up with one productive output. Now, it can be a website or it can be a product or whatever it is. Many governments came up forward and they started developing an idea of skill labs, a dedicated space that could have been there in the school itself or in the classroom itself, the regular classroom, but they had to give a separate name, they had to give a separate space only to emphasize on the importance of a place where that can have the composition of all the subjects and the knowledge that you gain. Maybe that is why it's called as Composite Skill Lab, something like that. Let's quickly understand in this session on what is the importance of Composite Skill Lab or skill labs in true essence of integrated teaching and learning, and this would give you a better perspective on setting up labs in the school. In case if there is any school who's looking forward to build your own lab system, want to have your own robotics lab or 3D printing lab, or a lab which is similar to adult tinkering labs, a lab that can have augmented and virtual reality, a lab that can have Internet of Things, a lab that can have artificial intelligence, and more importantly, drone technology as well these days. You can contact us, by the way. We will, this particular session is the product of the research of our work towards a lab system called as Da Vinci Lab System. So we are coming up with the name Da Vinci Lab, for one particular reason that the Leonardo da Vinci was never categorized under one particular domain. He was an architect, he was a physicist as well. He was doctor and he was able to design as well. So here I'm going to talk about Da Vinci Lab, which can encompass all the knowledge gained in various disciplines to be put into one and develop a product, a solution, a problem and a solution together. Let's understand that through this particular session. For that, I would like to share my screen right after this. And I would like to welcome each and every participant out there for our 154th session on Skill Labs. Thank you so much for joining consistently, teachers. I hope you're able to hear me and see me clearly. Yeah, right now you'll be able to understand concept. Many people say concept is important. Let's go for it. Understand this. Anyways, skill labs are not just a space of co-curricular activities. They're pedagogical engines of applied cognition that build something called as competence for the real world scenarios right now. So when I talk about pedagogical engines, I would like to very strongly emphasize the fact that the teachers now are not going to just prioritize the knowledge. They're going to make sure there is a lot of skill sets gained in the process of going towards the knowledge. And that's why we need to bifurcate this knowledge into multiple aspects. Something called as what is a knowledge, then what is intelligence, and what is wisdom, what is information. Understanding these nuances of just knowledge will give us better perspectives in teaching methodologies. And that's why it is coming under the category of pedagogical engines of applied cognition, basically the brain part that build competence. So what are we really getting into? So we are getting into skill labs. And first of all, before getting into that, let's understand the need. The need for skill labs is not just about having an experiential learning among the students, which we think is right. It's actually from various boards across. In India, CBSE has been one of the most common, and even ICSE for that matter. And gradually, eventually, the Cambridge and the IB curriculum is also present across the school systems. And there are different set of schools like Waldorf Education System. And then there is, Krishnamurti Foundation schools. which are more into, residential schools of Gurukul system, and there again they get into hands-on work. Lot of boards coming up with various education methodologies. If you get to all of them and talk about one common thing, and that is everyone talks about skilling framework. International Baccalaureate says that design thinking process of problem solving is really important, and they start with empathizing with the problem, and from there it starts to development of a prototype that can solve a particular problem. In fact, the whole theme of International Baccalaureate curriculum is the ability to convey the message, understand the emotions, and that particular aspect is present in the curriculum document of IB as well. And it talks about skilling through design thinking process. Interestingly, Cambridge curriculum again talks about International General Certificate of Secondary Education. IGCSE talks about multiple combination of subjects. You take maths and then combine that with accounts. So maths could be concept and accounts could be something related to skills. You look into this website, they'll talk about various combinations of concept and skill. And that's how the suggestions of various leaders under IGCSE, a suggestion of various teachers under IGCSE can tell you how well a student can establish a good combination of a subject. Third is CBSE, Central Board of Secondary Education, talking about composite skill labs and skill modules introduction. In fact, I would like to show this to everyone. There was a circular on composite skill lab emphasizing the importance of mandatory inclusion of skill subjects. See, look at this. Setting up of composite skill labs in CBSE schools. As you're aware that the National Education Policy and the National Curriculum Framework for School Education, NCFSC, has focused significantly on enhancing skill education, particularly for students in classes 6 to 10. So it has also advocated the inclusion of skill subject as an integral part of the curriculum by including it as a mandatory subject of study from class 6 onwards. Again, with Kaushal both, they've released the same circular in 2025, emphasizing on mandatory inclusion of skill modules. It stresses the importance of equipping students with practical skills alongside traditional academic subjects. So here, when they talk about this particular aspect of Composite Skill Lab, they talk about various aspects of it. So for example, it should comprise of STEM labs. Probably it should combine the arts as well. Probably it should have the ability for the students to have a lot of hands-on even in languages. This has gone to an extent where recently there was also circular released on virtual skill labs. Now virtual skill labs has been talk of the town since pandemic. Many initiatives, one of them called as O Labs by Government of India, has been in term. I think you would have used O Labs. It is there for all the subjects right now. Earlier, O Labs was only for science and maths, especially from 9 to 12th standard students, where you can have virtual experiments. So I would like to request all the teachers out there, if you have not used O Labs before, I would humbly request you to please try that right now. It is very simple. It's also there in the form of O Labs. Just search O Labs with Amrita Vishwa Vidyapeetham. So it's one of the greatest initiative, and there was also a proper. Okay, I would like to click on O Labs. You open one of the links, you'll get it. But right now, I think this particular website is down. No, it is up. So physics, chemistry, biology, maths, language, science, social science, computer, 3D, AR, VR, EDP, ISL, and you click on any one of them, and you will get the list of all the experiments for class 12, for class 10th, for class 9th, all the classes basically. So you know it. Most of you might know about it and you might have been using it. The point is virtual skill labs is being the focus very recently. Again, they're emphasizing on use of it. So when we talk about all these initiatives by CBSE, skill modules introduction, again, there was a list of subject where it is more of combination of not just the concept, but also the ability to make some money, which is again related to something called as vocational education. So the students get an opportunity to make a product and sell them. I'll repeat it, sell them. They can use the skill to sell themselves. So if I click on skill modules introduction, it will talk about carpentry, it'll talk about 3D printing, or it will talk about, something related to beauty and wellness. Probably it can talk about handicrafts. I hope you're getting the point. So again, CBC is emphasizing on that as well. ICSE is coming up with, not coming up with, they were one of the initial people who talked about artificial intelligence and robotics curriculum. I think for the last, I think 2 or 3 or 4 years back, right before the pandemic, this article was already released called as 66 Robotics and Artificial Intelligence, and where they spoke about direct 100 marks for robotics and 100 marks for artificial intelligence. They even gave a framework, but an actual content is still not very clear. So every school is having their own methodology on adoption of taking robotics and AI. If anybody would like to get more clarity on that, kindly contact me separately. You have my phone number on the slides and also on the reflection form. So that's about ICSE coming into picture. And finally, Ministry of Education, Niti Aayog, one of the groundbreaking revolution, I would say, called as Atal Innovation Mission. One of my favorites. Through Atal Innovation Mission, there was something called as Atal Tinkering Labs. And Atal Tinkering Labs set up by Government of India in various schools, talking about innovation. But here, Atal Tinkering Labs focused not just on innovation, but on making a product, which they called it as MVP, minimum viable product or market viable product that can be made by the students and sold across. I have some of the MVPs today. I think I can show that to them. I'll give me some time. I'll just bring that in few minutes. But the point is, when we talk about market viable product, it is all about students coming up with an idea and quickly making an object that can be immediately put to use. So how about having a lab in the school? Say for example, Da Vinci lab is set up in some of our client schools, and the children have made an activity that is put to use regularly. So one of those client schools that we have here in Bangalore, the children have made an hand sanitizer, an automatic hand sanitizer. So it is actually kept in the classroom door, and the children, they just show their hands and the sanitizer, just gets dispensed. It's done by the children using simple sensors that are available at the local stores with open source materials. So it's about viability. It is about usage of materials. So this is another aspect of Ministry of Education. I would like to request all the teachers out there to whatever I spoke about these boards and understand why everybody's emphasizing on skill modules. I would like to stop sharing the screen right now for a few seconds and talk about this for a few minutes. Now, when we talk about integrated teaching, yes, we'll talk about it. Okay. Okay, now coming to the point. 1 second. Coming to the point. Yeah. So when we talk about skills, let's understand this. What is really important? Are we talking about concept to be more important or skills more important? Now, when we talk about the aspect of skills, many people think that skill is prioritized and concept is prioritized. But in brain, when the learning happens, they both happen very close to each other. It's like the first minute when a teacher is talking about a certain aspect of a concept, the children are listening very carefully from knowledge perspective. And the moment they understand a certain statement by the teacher, immediately they connect that with a real life application of it. So, for example, anything related to circles, the teacher is talking about probably patterns and circles in mathematics. And immediately children will be like having a picture of circle, not just on the board, but more from real life orientation. Probably circle could be thought as the shape of a moon, or it could be thought as the steering wheel of a car, or it could be thought as the ring that they use to swirl around, or the balloon that they use in the swimming pool. It could be anything. But the point is they start connecting that particular aspect with that. So somewhere an application of what's been spoken is imagined by the children constantly when the concept is delivered. I'll repeat it. The application of whatever is spoken by the teacher may not be in its complete nature, but at that particular moment, there is going to be a certain level of imagination by the children. Now, this is exactly the place where it's important for the teachers to get the students to their surrounding and give examples according to that. Now that the examples are given and the children have got a fair understanding of what's being spoken about, right after this, it's important for the teachers to have a hands-on activity on that particular thing so that that gets reinforced. As simple as that. What we intend to say is, I talk about, say, a concept in, light, electromagnetic waves. Ninth standard students. Light has got this beautiful aspect of reflection, and it can travel without a medium. And when we talk about electromagnetic waves, One of the best examples is light. The teacher is talking about it in the class. The students are trying to understand light. Okay, I'm able to understand the sunlight or the tube light. It's just coming and it's able to bounce. And then the teacher makes a statement. Did you know the light can travel even without a medium? Then immediately teacher gives a solution stating that there's something called as vacuum. And in vacuum, the speed of the light is maximum because there's no air that can obstruct the light. Again, the children are trying to imagine something. But the third aspect is immediately the teacher is saying, hey, children, do you remember? You would have seen that whenever you try to keep your hands under the tap water, automatically the water comes. Have you gone to a hospital or have you gone to a mall where you just stand near the door and the door automatically opens? Now the children are trying to connect. They're saying that how is light related to this particular aspect? The teacher continues to say that, did you know when you go to the hospital or when you go to the malls, when you stand near the doors, there's going to be a sensor right on the top. The teacher doesn't stop over here. She says that that sensor consists of two important things. One is transmission and another is reception. So transmitter and receiver are two devices that are present on the top, and transmitter emits IR rays, electromagnetic waves, infrared rays that you can't see. Otherwise, it will be disturbing. Yeah, as simple as that. So when the IR rays touches you, it bounces back from you and the receiver receives it, and the door understands somebody has come and the door opens. Light need not be always visible, and the light that is visible is called as visible spectrum. And this particular area where you go to the door automatically opens. It's basically called as an IR sensor or a proximity sensor, which works absolutely with the principle of electromagnetic waves. Now, this is where the conclusion happens. The children have an ability to understand electromagnetic waves with the right examples that they can see right outside the class. Now, the teacher is taking the students to the lab where the children are actually given the original IR sensor. So it's like, students, look at this particular sensor, IR sensor, you can have it. Now this IR sensor, you can see that there are two LEDs. The one on the over here, it's called as transmitter. This is called as a receiver. Or else you can show that on the board and you can talk about it. When the children are like, ma'am, can we program this? Yes, you can absolutely do that. You can absolutely do that. And can IR rays understand which person is coming? Can they do that? No, IR rays cannot understand which person is coming. But if I combine my IR sensor with a camera, the camera can understand who is coming. Now artificial intelligence is coming into picture. The point is, the expansion of the chapter of light or electromagnetic waves can go to any extent, provided you have the right skill lab in the school or the right materials with you at the school, even sonar for that matter. That's a beautiful point. I hope you're able to understand. I remember one of the computer science teachers the other day so beautifully. I did not know until 10 minutes that the teacher was actually a computer science teacher. She was talking about the ability of light to carry information, the pictures. So it seems that there is a certain technology, let's not get into the details of it, where the light can carry information from one place to another, and the light travels really fast. So what people did is, this information they put it in the form of a wire, which they later started calling it to be fiber optic cables. Optic, why? Because the light is traveling inside. And the beautiful part is, the teacher is continuing to say, this children are like, light travels in a straight line, but the cables bend from all the different directions. So how is it possible? The teacher says that the bending can happen, but it does not affect the total internal reflection property of light. The light actually does not travel a straight line, it follows a zigzag path. That's how the medium is created inside the cables. Now, for all the teachers who have an idea of what is total internal reflection, you'll be able to relate to what I'm saying. That is why today, as per the computer science teachers, and she's so right, that the internet travels through light, and that's why those cables are called as fiber optic cables. Ability of a teacher of computer science to connect the fiber optics with computer science and science. That's where integrated teaching comes into picture. How about the teacher taking the students to the lab, removing one of the cables of internet and just showing that this is how light travels, or show it on the board, or have a skill lab where that could be shown. Skills are not byproduct of concept. I'll repeat it. Skills are not byproduct of concept. Skills are part of the concept so much that even to understand the concept, skills are required. Sometimes you would have understood that to understand a particular concept, you keep doing the same thing again and again. Keep doing the same thing again and again so much that you understand the concept. So there are certain curriculums like IB curriculum where they don't really focus on terminologies or jargons of concepts. They focus only on improving the skill sets. And the more they get hands-on and improvise on the skill sets, one day they'll understand the concept, and that's the idea. So what's really important, concept or the skill? You can't say skill alone, because skill is done just to improve the concept. Let's have that debate for forever. So let me can we teach all topics in all subjects like this? Sir, it's mandatory right now. That's the biggest issue. It's mandatory that we have to teach all the subjects like this. Now, for this, I would like to come up with an analogy, teachers. This will give you a very good perspective. Now, this is called as knowledge. What is knowledge? When do you see a person is knowledgeable? We say a person is knowledgeable, or no, when they understand what they have learned. So, for example, I know what is condensation. Let us take an example. Condensation is the process by which water vapor changes into liquid when it cools. Let's understand, condensation is the process by which water vapor changes into liquid when it cools. Now, this is all about understanding, like remembering, recalling, and responding. Knowledge is information at this particular stage. But if I have to get more clear about it, I go to the next stage where I called about intelligence. It's like I understand. In the first case, I know. Now it is I understand. Why do water droplets form on the outside of a cold bottle? So when you keep water bottle outside right after the, like from the fridge, refrigerator, it immediately has the water droplets outside. How did it bring the water droplets? So it's like when warm air touches the cool surface, the water vapor cools and turns into liquid droplets. Now, this is where I understand condensation. Connect, apply, reason. Intelligence is understanding. I hope everybody's there with me right now. Now comes the best part. Now, this part is called as genius. Now, this is where I create. How can this idea be used differently? See, I can design a device that collects condensed water from air in humid regions, and I can make water. This is called as imagine, design, build. Genius is innovation. I think you would have seen this in deserted areas where the water is scarce. People take, ice. They decrease the temperature of a certain object so much that the external aspect of that particular object starts collecting water droplets from the air. Why? Because air comprises of water, and that water is collected and people use it, consume it. As simple as that. So this particular aspect of knowledge to intelligence to genius is what a skill lab should talk about. I'll repeat it. I'll repeat it. So knowledge, I know. Intelligence, I understand. Genius is I create. It's very simple, or comparison to Bloom's taxonomy as well. But this atmospheric water generator, you're right, Bindu ma'am. Nowadays, we have fog collectors, exactly. But the ability of a child to know that fog collectors is actually from the process of condensation, that is also very important for us to understand. See, there is always a gap between cognitive domain and psychomotor domain. I'll repeat it. Knowledge and skills. People know that this is how it works, but they don't really know that it is condensation. Many teachers have come to me and told that, see, whatever you speak about, I know. It's just that I don't know the jargon of it, the original term. Last time also we were talking about it. Why do people have so many terms? It's important for these terms because terms bucket information, and this particular information can be further examined, explored, so you can't avoid it. I mean, you should not avoid it. So if you don't avoid it, you will get to learn more. But at learning stage, they're actually not important, not much important at all. Let's understand the concept, then skill, and then finally, oh, this is why it is called as like this. If I have to support whatever I spoke right now, I need to tell one simple example that actually what really happens is, I'm just stopping the screen share. When you take a closed loop, say you have a Y-shaped tube, I'll repeat it, Y-shaped tube. And this particular tube is hollow in nature. Okay, that's Y-shaped. You actually connect syringes in all the four, or no, three, two over here and one at the bottom, wherever you want. Now when you actually inject water in one of the syringes and press them, the other two syringes actually gets expanded. And interestingly, they get expanded simultaneously. So it's like you press it and both get expanded. The biggest advantage of this particular methodology is that if I have to move an object, and if I simply press a syringe from one side, which has got fluid inside, it can expand the other two objects easily. This is applied in a lot of places, especially the dumper trucks. Have you come across dumper trucks? Dumper trucks, you would have seen that they press a lever and the truck just gets opened up and then the materials fall down. Or else this could be applied in car braking system. When you apply the car brakes, what really happens is the syringe is pressed. It takes the fluid out and puts across 4 tubes. And each of these tubes have got 4 more syringes that are connected to the car tires. And this particular syringe gets expanded and they apply friction on the wheel and they stop the car. I hope you understood what I'm saying. The point is, when you apply the brakes, the brake oil gets transferred to all the 4 wheels simultaneously, and this particular aspect comes under the concept of hydraulics. And this was spoken by a person called as Louis Pascal, and that's why it's called as Pascal's law. I hope you understand. Like when we talk about Pascal's law, how about starting the class? Students, let's learn Pascal's law. No, we're not getting there. We're starting up with a very simple example of Y-shaped tube. And then we're taking syringe as an example. Children get connected better. That's why skill labs is important. Having these materials is important. Experiential learning is important. Let's quickly understand this with our final few slides. For that, I would share the screen. So genius, I create, how can this idea be used differently? So this is all about from information to understanding to innovation. From information to understanding to innovation. Da Vinci Lab, nurturing genius. The Da Vinci Lab is basically in our area, the focus is not just on information, not just on understanding, but on innovation. And that's why we call it as nurturing genius. Some of the pedagogical strategies with which you can emphasize on these skills is the 5E model. I think many people know when you teach people start with engage, explore, explain, elaborate, and in all the 4 stages, you can evaluate at any time to check if one of the stages. So engage could be something related to a bizarre concept, an example, a real life orientation. And then you explore through that particular orientation on what we're actually supposed to learn. And then you actually learn the concept and then you elaborate on it with further examples. So students stretch their knowledge through problem solving, research, STEM activities, designing experiments, etc. That's where elaborate comes into picture. And this is where Da Vinci Lab comes into picture. Let's understand further. There is one more thing called as KWL model. What do I already know? What do I want to know? What did I learn? This is more from a teacher-centric approach where the teachers try to jot down what do I already know and what do I want to know. That is like the prerequisite knowledge and the learning objectives. And then finally, the children probably say what did they actually learn. This is called as KWL chart. Let's go forward and understand computational thinking. Now, when you talk about computational thinking, it is about a process of problem solving again. Whenever you get a very big problem, you try to break it into small parts. That's why it's called as decomposition. Breaking big problems into smaller, easier to manage problems. Right after understanding multiple problems are there to a very big problem, you try to understand the pattern in that. So that's why I call it pattern recognition. Look into all the small problems and you'll see that there's a pattern. If you solve that particular pattern, the complete problem gets actually resolved. That's why it's called as pattern recognition. And right after that is abstraction. Now, abstraction is the ability of a person to ignore the things that are not required right now. So you remove abstraction. And then right after that, you have got something called as algorithm design. It is all about writing step-by-step procedure to solve that one problem in the pattern. Nice, no? Decomposition, pattern recognition, abstraction, and algorithm design. This is called as computational thinking model. And this is exactly the way the computers work. And maybe that is why it's called as computational thinking. Nice, no? Let's go forward and understand the next model. Design thinking model, which all of us know. We call it as ADIPT. ADIPT in the sense empathize, define, ideate, prototype, and test. So it's like whenever you face a problem or you want to solve a particular problem, whoever is facing that problem, you need to talk to them. Understand the real problem. If you are making a product related to irrigation, talk to the farmers. If you're talking about a problem in the classroom, talk to the teachers. Understand the pain, empathize with them. Only then you'll be able to define the problem. Sometimes what will happen is you have a problem, you try to solve it, and then you finally understand this problem was never solved. I hope you understood. For example, I have a latest information. There was a friend of mine who was always having a lot of problems with his wife. He said that if I just disconnect her from my life, definitely I'll be happy. Fortunately, God blessed him, and that lady went to her hometown for nearly 6 months or 7 months. Again, this fellow was not happy. So this fellow's problem was not with his wife. He understood the problem was actually him and his parents. Nice, no? See, identifying the problem is lying with the parents or the wife itself is design thinking process. If you can apply that there, why not in a skill lab? Anyways, empathize, define the problem, then ideate a solution. Now, this solution could be on a piece of paper or it could be an activity. then prototype it at a smaller level, and then you test it multiple times. This is called as design thinking model. This is again, it's a computational thinking and design thinking both follow under, problem solving methodology. Then there is something called a C4 model, which is all about context setting, connect to real life, concept exploration, and competency building. Now here we talk about a super teacher C4 model, which is something that we use to write our computer science curriculum. It's quite open. Anytime we talk about any particular topic, it has to start from a context point of view. Remember, in last session we spoke about integrated teaching and learning, may contextualization. Yeah, giving a scenario for the students to get into that zone, and then trying to connect to real life from there, and then explore the concept, and then find a solution to solve that particular problem. And that's why it's called as competency building. So C4 model, if I have to quickly share with you, for that I would like to share my screen. I think you're able to see this. And let me check if it's okay. So this is our DaVinci Lab manual. And this is how our computer science, no, not makerspace activity book. I'm directly opening it from there only. So here you can see that it's a third standard book. So I would like to zoom in a little bit. So with our DaVinci Lab, we also give the computer science or the book, the lab manual. You may have noticed that sometime when you or your parents connect a new electrical device at home, the electricity suddenly goes off. Have you seen about the tripping meter? Lights stop glowing, fans stop rotating, and everything becomes quiet. But this is not due to damaging the wires. There is no smoke, no burning smell, and no sparks. Then someone goes to the electrical board and flips a small switch, and the power comes back. Why did the electricity go off suddenly? What is that special switch that brings it back? Let's explore. This is called as contextualization, context setting. Now, this is called as understanding of circuits. For third standard students, we need to first build what are circuits. And for that, this is one of the activities that we do. Now, inside the devices around us, this is called as connect to real life. Now, where we talk about what the children already know. A toy car moves when we press a button. A fan starts rotating when we switch it on. A television shows pictures when it is switched on. So we talk about that particular example, and then we talk about electric circuit. This is where concept exploration happens. And when the concept exploration happens, we talk about concept exploration and connect to real life parallelly multiple times. And by the time when we complete, we come up with competency building. Now, this is where lab comes into picture. So I go down a little bit more. I go down a little bit more, and there'll be an activity which the children can do at the lab that is set up in the school, where a science teacher can probably take the students over there. So what is a series circuit? What is a parallel circuit? For a third standard student, do you really think they'll understand? Ma'am, you'll not believe. They absolutely understand. It is not about the difficulty of the concept. Trust me, it is about the ability to convey the message. And then we have virtual lab experiment using tinkercad.com, building the basic circuit on virtual scenarios, and then bringing the students to the lab and doing it in a physical scenario. Now this is building the basic circuit real, and the children actually use the wires and everything, and they build it. Then project birthday candle paper circuit. Now this is paper circuit where the students actually draw using pencils. And once that is done, one more project, double paper circuit. And by the time when it gets completed, by the time when it's completed, so we come to the conclusion over here. I'll show this to you. Ah, now we know what an electric circuit is, and that advanced circuits work the same way as simple ones. Let's get back to the situation where electricity suddenly goes off and the smart switch. The electricity goes off because miniature circuit breaker MCB acts like a smart switch and opens the circuit when too much electricity flows. This protected the wires and devices from damage. When the switch was turned back on, the circuit closed again and electricity flowed normally. This shows that from a simple switch we use in a circuit to form or to a smart safety device like an MCB, the idea is the same electricity works by opening and closing circuits. That's it. So here the context gets closed. Context setting, connect to real life, concept exploration, competency building. So this is our lab manual where the children explore, then the worksheet comes into picture, and they actually get to do the activity. Now for this, I would like to show you some of the activities instead of just showing. I have it with me. Just give me 30 seconds, teachers, 30 seconds. So these are some of the activities that the children had made. I would like to thank the school for allotting this to me. So say for example, okay, I would like to show this to you in a minute. The video has gone blank. So here we go. Okay. Am I tilted right now? Yeah, I am tilted right. This is what happens when suddenly we get an idea and try to. Okay, perfect. Okay, so now this was one of the activities done by the children on dustbin, automatic dustbin, a table dustbin. Like it's quite simple. You can keep it on the table, you can sharp and put the dust over there. Now here the children made on a science exhibition that was themed around Swachh Bharat or something like that. So they've got a microcontroller that is open source in material called as Arduino Uno, and they've got a sensor of ultrasonic sensor right on the top over here, and then they have got a servo motor which is connected to a string, and when the dust is or garbage is detected, the servo motor rotates and it actually gets opened up. I'm not able to connect the wire in short time and show this to you. So this was one of the activities done by the children, which is my point is minimum viable product. So it's not like it's just present over there on the table and you can't ever use it. You can use it actually. These are all hard materials that the children used. And for this, you need to have another thing machine in the lab, probably called a CNC machines, where the children can design the bot and they can print it out or they can cut it. That's why 3D printing is important. So DaVinci Lab system, which the children have made across, it has got 3D printing as well, which is another 3D printed object over here. This is again alcohol detection. And you've got the way to program transfer. And again, if you open this up, you will get again Arduino boards and things like that. So these are some of the activities that the children can do with the lab manuals that we give. So when you talk about skill labs, it's more from the perspective of um, you know more, I'll share all these activities if required. In fact, if you want, you can contact us and I will show you our LMS, which has got all the activities. Some of you already know the user ID and password. So if you want, you can just message me directly. I shall give you some of the activities. A lot of them are there. One more is IoT based activities, which we call it as weather station. And this is how the weather station actually looks like. See, you've got all the station along with the display module. It will tell what is the temperature, air quality index, everything. So this was again another activity. So again, see, all these activities are minimum viable. You can keep it right in the school right now in front of the probably the main gate or the principal's table, and it will give you an actual measurement. So that's where MVP comes into picture, and Atal Innovation Mission talks about entrepreneurship through that. So let me check if I have it. So, so this is how our LMS looks like. And right now we have set up multiple DaVinci labs across the country. And if anybody's interested in that, you can actually let me know. We can set up lab at your school as well. So we call it as DaVinci Lab system, and I've got certain activities over here. So if I click on grade 6, all the activities will look like this over here. So a drone technology, AI nutritionist, and I click on the lesson. Okay, let's go with the ebook right now. And again, the context setting will start over here. So this is how it looks like. Byte AI and Caller AI are a few names that have become a buzzwords these days among health enthusiasts. You scan your plate and it will tell the protein, carb, fat, and other nutrient contents. It keeps note of it and gives you a great insight of your eating pattern. In this activity, we'll explore what is the technology behind this, how do they relate, and then we have got science connectivity, maths connectivity, and then you remember KWL model that is also done. What are the base components that are required? And based on that, the activity happens, and then there is activity junction and the children do it further. The materials are provided to the schools by SuperTeacher team. In case if anybody is looking forward to set up a lab, the reflection form will consist of a question related to that. You can say yes or no, and at least we can give you the idea on how to do that. So the wiring happens, and that's it. Then Google Teachable Machine AI API to be integrated, and the activity gets concluded. So when you look into DaVinci Lab systems or DaVinci Labs in the school, it's a function of application of what's taught in the class through various methodologies. So let me stop sharing the screen for a few seconds and talk about it, and then we'll conclude. So CBSE, IGCSE, or ICSE, or IB, all of them talk about skill labs. And right now, I would like to tell you three important things. The first one is called as the school education. Second is graduation, and the third is industrial requirements. It's important and imperative, in fact, right now, that the speed at which the industrialization is happening, the speed at which the industrial developments are happening, it's important for the school to cope up with that. Now, industrial requirement should talk to graduation, and graduation should talk to the school education. If this conversation happens smoothly, that means there's really good education system in that particular country. Through DaVinci Labs or adult tinkering labs or any lab setup that a school has done or is about to plan and do it, it's important for you to understand that the implementation has to be successful towards one particular goal, probably solving a problem or making a minimum viable product, or towards entrepreneurship. What is the ultimate vision of that particular lab is something to be established. That will make the students gain all the subjects and disciplines knowledge to apply to solve real life goal over there. So in fact, through skill labs, the subjects become the tools to actually solve a particular problem. Nice, no? That's it. That's it. So DaVinci Labs, in case if anybody's looking forward to, you can just contact us and we can set it up. That is something I would like to establish in this particular session with an experience of working at adult tinkering labs and the content being available online. We have got a lot of favoritism towards following the government footsteps, composite skill labs, and various other aspects. So when we talk about minimum viable product, it's the place where generally most labs actually fail. What really happens is you don't have good trainers or good resource person at the school, but you've got all the materials. So training is a problem. You've got very good hardware, but you don't have a very good software. So if I have to conclude by saying any lab consists of four important areas, you can make a note of it if you want to. The first one is hardware. It should be easily accessible. It should be readily available, and it should be programmable according to me. So first one is hardware. Second is software. You need to have the open source softwares to make it, build it, again erase the program, make it and build it. Probably a learning management system to guide the students with prescriptive activities so that they can develop something more beyond that, by themselves. So first one is hardware, the second is software. The third is the most important, it's called as a curriculum. Now, randomly, students cannot learn anything. Yes, of course they can, but the learning does not really complete its curve. The learning curve does not get. So it's important for the children to have the right curriculum. Now, this curriculum can be provided by IB, IGCSE, CBSE, or ICSE, or by SuperTeacher for that matter. Da Vinci curriculum. That's called as the curriculum. And the fourth one is the most important, according to me. Most of labs actually fail because of this, and this is called as the training. The right training to the right person. The teacher who is coming and training the children, they should be trained on what these are. So science, max teachers, computer science teachers are generally considered to be ideal for this, or even an external trainer who has an experience of working on this. That's it. That's it. So that brings me to the end of the session, teachers. Thank you so much for joining on another session, another Super Sunday workshop. And this time we got into skill labs. Set up a skill lab at your school. If you want to have an inspection, you can just contact us. I'll be able to be there at the school and do a decent job. Yeah, I've been working on this for quite some time. I can definitely say that the conversation that I would have with you during the inspection process, I can make it the highest or the most productive. Thank you so much, teachers. Great interacting with one and all. I would like to meet you again in the next Super Sunday workshop. Until then, yeah, thank you so much and Jai Hind. Thank you. Thank you so much, teachers. A lab could look something like this. I think I have a PDF of it. Uh, okay. I'm sharing my screen and showing that to you. Yeah. So I'm sharing the screen. I would also share the presentation with all of you right away. And I think you're able to see this in 3, 2, and 1. So our Da Vinci Lab consists of these 7 areas: robotics and automation, 3D printing, artificial intelligence and machine learning, Internet of Things, drone and aero modeling, augmented virtual reality, and space exploration. Knowledge, intelligence, and genius. And I have a picture. Yeah, this could be picture. So you can see that a lab which has got the soldering station separately, discovery hub, instructor and presentation arena, mechatronics station, coding and AI station, rapid prototyping station, multiple stations, and the methodology, design thinking approach, C4 learning model, and 5V instructional framework, and different kits that can be used. That's it. PPT is coming on the chat in few minutes, ma'am. Yeah, session 154, skill labs. Today's reflection form will not have question and answer. Okay. Yeah, great. Thank you, Valli ma'am. Thank you, Nidhi ma'am. Thank you so much, Paramjit ma'am. Thank you, Pragya ma'am. Meena ma'am, thank you so much. Kindly message me, please. Bini ma'am, thank you. I'm sorry, ma'am, I don't have a Hindi presentation. काश होता मेरे पास. Thank you, Valli ma'am. Yeah, happy Holi. So Namamal, thank you so much. Yashoda ma'am, thank you. Shabana ma'am, I will. Thank you. Thank you so much. Geeta ma'am, Sridevi ma'am, Farisa ma'am, thank you. Have a Super Sunday, teacher. Spend time with your family. I'll see you again in the next Super Sunday workshop. Bye, everyone.